Physicists say that the universe had its start in an event known as the Big Bang, generally 13.7 billion years ago. This event marks the beginning of all that we know in the universe, an extraordinary explosion that led to all matter, energy, and existence itself. The theory of how things came to be has long been the predominant scientific explanation for the start and evolution of the universe, describing a moment when the universe rapidly expanded from a hot, dense state into the vast universe we observe today. However, while this theory offers a framework for understanding the universe's early development, it leaves many questions unanswered. One of the most captivating questions is what triggered this immense explosion. If the Big Bang was the start of everything, what caused it and why did it occur? These are questions that have fueled the curiosity of scientists for many years, leading to intense study, discussion, and observation in the quest to understand the origins of our universe. Over time, researchers have continued to explore and study both the science and history of our universe. The Big Bang theory has been the most dominant explanation for everything we see, from the distribution of galaxies to the cosmic microwave background radiation, the faint glow of the Big Bang itself. Countless studies have been conducted over the years, with thousands of scientists around the world dedicating their careers to uncovering the mysteries of the universe. The data gathered from these studies has consistently supported the theory of how things came to be as the leading model for the evolution of the universe. According to the theory, a mysterious force known as dark energy plays a pivotal role in the ongoing expansion of the universe. Dark energy, which is believed to be far more abundant than the energy found within galaxies, acts as a repulsive force that causes the universe to expand at an accelerating rate, opposing the gravitational forces that would normally pull everything back together. The field of cosmology has advanced significantly over time. As technology progresses and we develop new tools for observation and experimentation, our understanding of the universe continues to evolve. Many things we once accepted as absolute truths have been shown to be incomplete or even entirely wrong as new evidence becomes available. A prominent figure in modern theoretical physics, Michio Kaku, has pointed out that even the theory of the universe's origins, long considered the foundation of cosmology, is now facing challenges. Recently, observations made by the James Webb Space Telescope have sparked significant debate among scientists. The telescope has identified 750 new galaxies that appear vastly different from what was previously predicted based on past models. These startling discoveries are compelling researchers to reconsider established theories and delve deeper into the mysteries of the universe. As these revelations unfold, they hold the potential to reshape our understanding of the cosmos. The James Webb Space Telescope, with its cutting-edge technology, is changing the way we view the universe. The findings it has made so far have pushed the boundaries of our knowledge, particularly regarding the formation and development of galaxies. The telescope has captured images of many galaxies that challenge previous assumptions, leading to a new perspective on the universe's evolution. These discoveries are exciting not only because of what they reveal, but also because they challenge long-held beliefs about the Big Bang. For those eager to stay informed about the latest advances in astronomy and cosmology, the images and data coming from the James Webb Space Telescope offer a fascinating glimpse into the farthest reaches of space. The newly discovered galaxies, with their stunning structures and astounding numbers, are prompting researchers to revisit their theories and explore new possibilities regarding the universe's beginnings. The James Webb Space Telescope has delivered some of the most breathtaking images of galaxies ever captured. In a single image, one can see countless galaxies grouped together. Their beauty and enormity are surprising to the average person. However, for professionals and experts, these images are not just visually striking. They are also profoundly astonishing. The galaxies captured by the telescope are vastly different from what scientists had expected based on the Big Bang model. They appear smaller, more diverse, and surprisingly old, raising questions about the accuracy of existing cosmological theories. These surprising observations are generating waves of concern within the scientific community, with some analysts even using the word panic to describe the reactions to these new findings. The discrepancies between what was previously expected and what has been observed are driving scientists to re-examine the fundamental assumptions of the Big Bang theory. For years, The theory of how things came to be has served as the primary explanation for the origins of the universe. According to this theory, approximately 13.7 billion years ago, the universe began as a single, unimaginably hot, dense point that rapidly expanded in what is commonly referred to as the Big Bang. This explosive event set into motion the evolution of the universe, ultimately leading to the formation of galaxies, stars, and planets, including our own. However, the new images captured by the James Webb Space Telescope have cast doubt on this long-accepted story. These images challenge the established narrative of the universe's beginning and have opened the door to further possibilities regarding how the universe came to be. The galaxies revealed in these images appear to be too small, smooth, and old to fit within the framework of the Big Bang theory, suggesting that the true story of the universe's origins might be far more complex than previously thought. One of the most striking aspects of the universe as seen by the James Webb Space Telescope is the size of these galaxies. These galaxies are several times smaller than those captured by the Hubble Space Telescope, which directly contradicts the assumptions of the Big Bang theory. According to this theory, as the universe expands, objects within it should appear larger as the distance between them increases. However, the galaxies observed by the James Webb Telescope are not behaving as expected. They are smaller and more compact, defying the standard model of cosmic evolution. Additionally, the smoothness of these galaxies is a surprising and puzzling feature. The Big Bang theory predicts that galaxies should show a significant degree of irregularity in their shapes, with noticeable variations due to the tumultuous processes of their formation and evolution. However, these new galaxies are remarkably smooth, with far less complexity than scientists would expect for galaxies of their age. This smoothness challenges the timeline of galaxy development and suggests that something about the standard model may need to be rethought. At the beginning of the universe, all matter, energy, and the building blocks of the universe were packed into a single point of unimaginable density known as a singularity. This singularity represents the starting point of everything, where the laws of physics as we understand them begin to break down. In this state, matter and energy were so densely packed that their behavior becomes difficult to describe using conventional physics. The nature of the singularity is rooted in Albert Einstein's theory of general relativity, which explains how gravity acts on massive objects. Within it, the density of matter reached an infinitely high value, creating conditions that we cannot fully comprehend or replicate with our current understanding of physics. The temperature at this time was extreme, far exceeding anything observable in the universe today. It is within the singularity that the seeds of the universe were planted, with all the mass and energy needed to create everything we see around us today. After the initial singularity, the universe began to expand and swell, going through a rapid process that stretched the fabric of space itself. This expansion, known as cosmic inflation, occurred at an incredible rate, far exceeding the speed of light. During this phase, the universe expanded drastically, smoothing out any irregularities and laying the foundation for the large-scale structures that would later form, such as galaxies and stars. Cosmic inflation played a crucial role in shaping the universe as we know it today. It homogenized the distribution of matter and energy, ensuring that the universe would be relatively uniform on a large scale. As the universe continued to expand, the rate of expansion gradually slowed, leading to the development of more complex structures. Scientists have been able to observe the effects of this ongoing expansion through phenomena like the redshift of light from distant galaxies, which shows how the universe continues to grow and evolve over time. During the early stages of the universe's development, all matter was compressed into a small volume, creating conditions that would have made it impossible for stable matter to exist in its current form. However, as the universe expanded and cooled, these extreme conditions began to change, allowing particles like protons, neutrons, and electrons to form. These particles interacted with the surrounding light and energy, eventually leading to the creation of matter as we know it. This process, known as nucleosynthesis, occurred during the first few minutes after the Big Bang and played a critical role in the creation of the elements that make up our universe. Interestingly, while scientists expected to see chaotic and disturbed galaxies due to various impacts during this early period, the images captured by the James Webb Space Telescope tell a different story. Instead of observing tumultuous galaxies, The telescope has revealed well-organized spiral and elliptical patterns that resemble the galaxies we see in the universe today. This challenges the idea that collisions and impacts were common in the early universe. The expanding universe theory, in which objects should appear smaller due to cosmic expansion, also fails to hold up against these powerful observations. The galaxies captured by the James Webb Telescope do not appear minuscule, raising further questions about the validity of the Big Bang theory. Additionally, the age and abundance of these galaxies challenged the idea that the universe followed a predictable path of development and evolution. The telescope's infrared capabilities allow it to focus on the light from distant galaxies, providing insights into the ages of stars and galaxies. This has led to the discovery that many of these newly found galaxies are much older than scientists had anticipated, further complicating the narrative of cosmic history. As we continue to learn more from the James Webb Space Telescope, it becomes increasingly clear that our understanding of the universe may need to be revised. The potential implications of the telescope's discoveries extend beyond re-examining the Big Bang theory. One significant aspect of this challenge is the role of dark matter and dark energy in shaping the universe's development. Dark matter, a mysterious substance that doesn't emit light or energy, is believed to make up most of the mass in the universe. Its presence can be inferred by observing the gravitational effects it has on visible matter, such as galaxies. Similarly, dark energy, a force that is thought to be driving the accelerated expansion of the universe, could play a key role in explaining the behavior of galaxies and other cosmic phenomena. Despite being invisible and mysterious, dark matter and dark energy may hold the key to unlocking the universe's true history. As scientists continue to investigate the universe's origins, the discoveries made by the James Webb Space Telescope, JWST, have opened up new avenues of inquiry that could challenge the foundational models of cosmology. Beyond just the unexpected findings about galaxy sizes and behaviors, the JWST has provided a glimpse into earlier cosmic history than previously possible, enabling astronomers to peer back further into the universe's infancy. With its unprecedented ability to detect faint infrared light, the JWST has begun to reveal galaxies and stars that formed mere hundreds of millions of years after the Big Bang, pushing the boundaries of what was thought to be the earliest stages of cosmic evolution. One of the most remarkable aspects of these observations is the unexpected diversity of galaxies. Historically, scientists assumed that galaxies in the early universe would largely resemble each other, developing from the same primordial soup of gas and dust. However, the new images show an astonishing variety in shapes, sizes, and structures. Some of these early galaxies appear to have developed much more quickly than anticipated, challenging the idea that galaxy formation is a slow, gradual process. This revelation forces scientists to reconsider the timeline of galaxy evolution and the processes that drive their formation, including the potential for previously unrecognized mechanisms that could have accelerated their development in the early universe. Another fascinating discovery made by the JWST concerns the age of the galaxies it has observed. Many of these galaxies, previously thought to be very young, appear to be much older than anticipated, raising important questions about the rate of cosmic evolution. Some of these galaxies seem to have already developed complex structures, including mature stars and even early signs of supermassive black holes, suggesting that the conditions needed for such phenomena to form could have existed much earlier than expected. This raises doubts about the initial assumptions of the Big Bang theory, which posited that galaxies would take billions of years to reach such levels of complexity. In addition to the unexpected diversity and maturity of the galaxies, the James Webb Space Telescope has also provided key insights into the chemical composition of distant cosmic objects. By analyzing the light from these galaxies, astronomers are beginning to identify elements and molecules in the early universe that were previously difficult to detect. These findings suggest that the process of star formation and element production in the early universe may have been much more efficient than scientists once thought. The presence of heavier elements, such as carbon and oxygen, in galaxies only a few hundred million years old suggests that the mechanisms for star formation and nucleosynthesis could have operated on a much faster timescale than the standard model predicts. The discovery of such mature galaxies at such an early stage in the universe's history also has implications for our understanding of dark matter and dark energy. Dark matter, which has long been known to play a crucial role in the formation of galaxies, is thought to have been present in significant quantities during the universe's early stages. If galaxies formed more rapidly than expected, this might imply that dark matter's influence was more profound than previously assumed. Similarly, the accelerating expansion of the universe, driven by dark energy, might also play a key role in reshaping our understanding of cosmic evolution. The interaction between these mysterious forces and the observable universe is still not fully understood, but the JWST's findings are providing a unique opportunity to study their impact on galaxy formation. Furthermore, the new data from the James Webb Space Telescope underscores the importance of developing new theories in cosmology. While the Big Bang theory has been a dominant framework for understanding the universe's origins, the new findings suggest that it may be incomplete or even flawed in some aspects. The early universe may not have been as uniform as the model suggests, and the process of cosmic inflation may not have been as simple as previously believed. Some scientists are beginning to explore alternative models that could account for the unexpected findings of the JWST. These models might include modifications to the standard inflationary theory, or they may incorporate new ideas about the nature of the universe before the Big Bang itself. The JWST's discoveries have sparked an intellectual renaissance in the field of cosmology. As researchers continue to analyze the data, new hypotheses and theories are being proposed that challenge established paradigms. The findings are not just pushing the limits of observational technology, but also prompting a reevaluation of our fundamental understanding of the universe's origins. In many ways, these discoveries are just the beginning. The universe remains full of mysteries, and as technology advances, we will continue to learn more about the complex and dynamic nature of the cosmos. With each new discovery, we come closer to answering the profound question of how everything began, though the journey may lead to even more surprising and unexpected answers.